Hello and welcome to Principles of Mathematics lesson number 15. In this lesson, we're going to learn about multiplication and division of integers. We'll look at models for multiplication of integers. We'll also look at properties of multiplication of integers, integer division, order of operations on integers, and finally inequalities with integers. So let's go ahead and dive in. Once again, the chip model provides a very nice visual technique. We can see here, for example, we have three groups of two red chips, and that pretty much is exemplifying 3 times -2, and we can see that we end up with 6 red chips, so the answer would be -6. What if we wanted to do a product of two negative numbers like this, -3 times -2? The way we do that is we start with a value of 0, which includes at least 6 red chips, okay? Because we know that 3 times 2 is going to give us 6, and because of the negatives, we want to make sure we include at least 6 negative red chips. So once we've completed that, we go ahead and remove 3 groups of 2 red chips each, and we end up with, if you notice, 6 positive chips. That's one way of seeing why -3 times -2 is 6. So think of that negative as remove 3 groups of these, basically. All right, next we want to look at the number line model. I know that with when it came to addition of numbers or subtraction of integers, I told you that it's easier to start with the first number, right? Don't start at the origin. Well, with these multiplication problems, you do want to start at the origin. I do recommend that. And here is I've created a graphic for you that makes it really easy to know what you're supposed to do. Like here, we're looking at +2 times -3. So think of that first positive as which way you should be facing initially. So notice in this case, the cat is walking and it's right at 0 and it's facing to the right because it's +2, right? Think of the 2 here as how many steps you're going to be taking, all right? Now, these aren't going to be single unit steps. They're going to be dependent on this next number. So this is going to tell you the size of each of your step. And finally, that sign right there of the second number is going to tell you whether you're going to take your steps forward or backward. In this case, notice that's a negative, so we're going to take backward steps. So starting here at 0, we're going to first of all face right, and we're going to take 2 steps of size 3, but in backward motion because of that negative. So we're going to basically take 2 hops of 3, and notice we would end up at -6. Try this with other combinations of variations on the signs of here, there. Make sure you practice and get comfortable with that. It's quite a lot of fun actually once you get a hang of it, and you can see why some of these results end up the way that they do. I do want to take a look at one more example with this number line of 2 negatives when we multiply 2 negatives. So we've already seen +2 times -3, and now we're going to take a look at -2 times -3. So remember that this is the way you're going to be facing initially according to this sign. Now this one is negative, so that means we're going to be facing left this time initially. We're going to take 2 steps of size 3, and notice that starting at the origin, we're going to take steps backward again. So this time we're facing this way, so backward would be going this way. See, that's why the direction you're facing initially is important, because when you're facing the left, going backward actually ends up going this way, right? So where you stop right there at 6, that's going to be your answer. So that's how you end up with positive 6. So understanding this little graphic that I've made for you will get all of these really cleared up for you. We can also explain this multiplication of integers using the pattern model. Let's say we want to look at negative 3 times negative 2, but using the pattern model. So what we'll do is we'll first look at 3 times negative 2, and we know that we can handle that using repeated addition because it's 3 of these characters here, right? So 3 negative 2's. And we get negative 2 plus negative 2 plus negative 2, and they're all the same sign. So we're just going to add and keep the sign, right? So we get negative 6. So now we can use the commutative property to realize that 3 times negative 2 is the same as negative 2 times 3. And both of them will result in negative 6. Now, let's take a look at the pattern. 3 times negative 2 is negative 6. 2 times negative 2, using the same kind of understanding, will be negative 4. 1 times negative 2 will be negative 2. 0 times negative 2 is, of course, 0, because 0 times any number is 0. Negative 1 times negative 2 should follow the same pattern now, right? Notice these are going up by 2, right? What doesn't change is the negative 2 factor, right? So notice that these are going up by 2, and these are going down 1 step each, right? So negative 1 times negative 2, if this pattern continues, should be what? 2. Again, negative 2 times negative 2, if the pattern continues, should be 4. Negative 3 times negative 2, if the pattern continues, should be 6. Very useful when it comes to pattern recognition, and then noticing that there is consistency indeed with what we're already familiar with, but again, not very, very useful when it comes to understanding why these products work out the way they do. All right, so I've designed this sign kind of table for you to understand. Notice that this works with both multiplication and division. So the way you use this sign table is you just do it like a times table. So positive times positive will result in positive. Positive times negative will result in negative. Negative times positive will result in negative, and negative times negative will result in a positive answer. So understanding this will help us get the right answer pretty much every time. All right, now that we have our multiplication division rule, as we can see here, and we have our addition and subtraction sign rules, multiplication division sign rules, of course I meant, and then addition subtraction sign rules, we notice that this gives us the ability to do a lot of the computations that we used to do before in a much faster and simpler way, okay? And we can pretty much start to drop the raised notation now and just deal with the level notation for signs, right? So basically, the way that we're going to handle things is the following. Even if we have parentheses, etc., as long as we're just combining integers, we're first going to use our multiplication and division signs to get rid of any parentheses that may exist. Then we're going to apply the addition subtraction sign rules to finish the problem up. Okay, so for the addition and subtraction sign rules, remember that if you're combining two numbers and they have the same sign, like these are both positive, we don't write a plus to the left of a positive number, right? The first leading positive number. So 2 plus 5, we just combine them by adding and keeping the sign. So this is going to be a positive 7. Notice here it's very similar. They're both negative. They're being combined. And we go ahead and add the 5 and the 2, gives us 7, and we keep the common sign, which is negative. So here you can think of having $2 in your bank account, adding 5 more, so now you have 7. Now, let's say you've become overdrawn by $2 and you write a check for $5. So now how much is your balance going to be? -7, right? Money is a useful way. Since we're so familiar with it, we've been using it for so long, is a useful way. Of course, if you've only used credit cards all your life, then that's not going to really help out. It's for people who actually handle cash, are pretty comfortable with this kind of explanation. All right, so like when they have opposite signs, like here are the two examples. The first one is negative, the second is positive. Here, the first one is positive, the second is negative. So when you combine integers with opposite signs, you're always going to subtract the smaller from the larger, and then the sign of the result is going to be the sign that's to the left of the larger number, because that's the sign of the larger number. The sign of a number goes to its left, right? So when you have 2 minus 5, we're going to go ahead and again subtract the 2 from the 5. That gives us 3. Now we have the sign of the larger number, which is negative. So we're going to, for the result, we're going to get -3. So let's see how this could help us simplify some more complicated expressions. Like, for example, let's say I have 3 minus -2. See, now I have a parenthesis involved, so that's what I meant by use these rules to get rid of the parentheses. Because notice when I write 3 minus -2, you can always imagine there being an invisible 1 right there, right? So so you can consider this to be -1 times -2. And remember, according to order of operations, you should multiply before you do addition and subtraction. So by doing so, we end up with what? We end up with 3 plus 2, which gives us what? 5. See how nice that is? Very, very easy to deal with. All right. Let's take a look at another example. Let's say we have 3 minus 2 minus 5 minus -11, right? So now we're going to, according to the order of operations, remember GEMDAS, grouping symbols first, right? Then exponents, then you do multiplication, division from left to right, then addition, subtraction from left to right. So we're going to go ahead and take care of the grouping symbol here first. So we end up with 3 minus, now 2 minus 5, we know is what? -3. And then minus -11. So I just want to take care of one thing at a time so we don't get confused, all right? So now we go through and we realize we have multiplications here. They're implicit multiplications. They're not very obvious multiplications, but they are. I notice I have a -1 times a -3 here, and I have a -1 times a -11 here. That's what I mean by apply these rules first to get rid of the parentheses. So now we end up with 3. -1 times -3 will give us +3. Remember, negative times negative is positive. So 3 plus 3, and then plus 11, right? Because -1 times -11 will give us +11, and we end up with what? With 6 and 11 is 17. Now, remember that I told you there's light at the end of the tunnel. Don't get discouraged with all the tedious work we had to do in the last video, because they do end up getting much, much easier once we learn both sets of these rules, okay? Okay, now looking at some properties of integer multiplication. For all integers a, b, c belonging to the set of integers, the closure property of multiplication tells us that a times b is a unique integer. In other words, whenever a and b are integers, then a times b, their product, is also a unique integer. The commutative property of multiplication tells us that a times b is equal to b times a. In other words, the order of multiplication does not matter. And the associative property tells us the grouping does not matter if we're dealing with more than two items, in fact, with three items, right? We can multiply the first two, then multiply the third, or multiply the last two and then multiply the first. For example, let's say you want to deal with 3 times 4 times 5, right? We want to know if that's equal to 3 times 4 times 5, like that. Now notice here we get 12 times 5. On the other side, we get 3 times 20. At first, they look different, right? But notice the left side actually ends up to be 60, and so does the right side. So yes, it checks out. That's what we mean by the associative property. All right. As we did with the whole numbers, of course, we have the identity property of multiplication, and the multiplicative identity is known as 1. So we call it the multiplicative identity. And that's because when we multiply 1 by any number, there's no change. It doesn't change the number. We get the number itself, okay? And it doesn't matter whether we multiply the 1 from the left or the right, of course, because of the commutative property. Now, the distributive properties of multiplication over addition of integers, we have the left distributive property, so you can distribute into this group from the left and get a times b plus c equals ab plus ac. And you have the right distributive property, which says you can distribute from the right and get BA or AB plus CA or AC. Doesn't matter how you write it. And I do want to remind you that just as in the case with whole numbers, this works with subtraction as well. So if you have A times B minus C, I get AB plus, or well, I'm adding the minus, so I'm really creating two sets of rules in the lazy notation of just using one set, okay? So when we put it like this, it means this works whether you're dealing with plus or with minus, right? In other words, A times B minus C is also equal AB minus AC, etc. The zero multiplication property for integers, of course, tells you that if you multiply 0 by any number, it's just going to wipe it out, and you're going to end up with 0, right? And if you look at the equivalent of that in the form of a times 0, it kind of makes sense, because you're getting no matter what integer that is, let's say 5 times 0, you're just adding 0 5 times, right? So you're not going to get anything new. You're just going to get what? 0. Few more properties. Of course, if you multiply -1 by any number, you get the opposite of that number. Negative a times b is the same as b times negative a, and they both give you negative ab, right? And when you multiply negative a by negative b, of course, negative times negative is going to give you positive, so you're going to end up with ab. Once again, here, the distributive properties of multiplication over subtraction, which I already mentioned in the last slide. Now here we want to simplify this expression using what we've just learned. Now remember, here we're just going to distribute the -3 by both of those. So this is going to be -3x, and then minus -3 times 2, right? Now that's -3x. Of course, remember, negative times, here you have a product of actually 3 numbers, right? What's one of the numbers? It's -1. Think of it that way. So what's -1 times -3 times 2, right? Think of it that way, and you get what? Negative times negative is positive, times positive is positive, so you get plus, and 3 times 2 is 6. So you end up with negative 3x plus 6 as the final simplified result. You obviously don't want any parentheses in the final answer. All right, so I'm going to show you how to do this in a couple of ways. First way is we'll use the distributive property. So we'll distribute x plus 4 and multiply it by x and then by 4, and we have a minus in between, right? So we get x plus 4 times x minus quantity x plus 4 times 4, right? So of course here we're going to distribute the x from the right using the right distributive property. So we know that x times x is just what? By definition is just x squared, right? So we get x squared plus 4x minus, now I'm going to go ahead and open a parenthesis here because I'm going to distribute 4 by x. I get 4x, and 4 by 4 gives me 16, right? Plus 16. But don't forget that now we're going to have to remember there's that invisible 1 here. So now we need to distribute that, right? So we get x squared plus 4x minus 4x, and don't forget to distribute the negative 1 by the 16 as well. So we get minus 16. So do notice that the middle 4x and minus 4x cancel out, right? Because they're opposites of each other. So in the final answer, we end up with x squared minus 16. Okay, now this may look familiar to you if you've had algebra before. This is when you multiply. Now, these two kinds of expressions, where the only difference between them is the sign between the two terms, these are called conjugates, right? So when you do multiply two conjugates, so let's say of the form first plus last times first minus last, it turns out you do always end up with a similar situation. So let me show you using a table. So I will multiply f plus L by f minus L using a table for you like this. So notice f times f will be f squared. F times negative L will be negative FL. Positive times negative is negative, right? And then positive L times F, that's just going to be positive FL. And positive L times negative L, that will be negative L squared, right? Notice that the FL and the negative FL will cancel out, so we just get what? We get F squared minus L squared. So when you look at it in this direction, that's called the product of conjugates. But you can also remember we always learn mathematical formulas in both from left to right and right to left. So if you observe it like this, so in the left here you're multiplying conjugates. On the right here, you're factoring a, what does that look like? Those are two squares, right? So a difference of squares. So for example, if I say to you, now the multiplication is simple, but I told you I was going to show you another way for that. Well, that's exactly this box method, right? Like we did over here. So you could have gone x plus 4, x minus 4, and you would get what? X squared minus 4x, and then the box down below to the left will be positive 4x, and then negative 16. We notice again these two cancel out, so the result will be what? Same thing that we got here, x squared minus 16. Now, with this formula that we've given here, you should be able to take an expression that has that form and then factor it out as these as the product of these two factors. So, for example, if I say to you factor u squared minus 64, right? You notice that what's playing the role of f here is u, and what's playing the role of L here is 8, right? Because what is it that you square to get 64? It's 8, right? So if interested, you could have first written it in fact as a difference of two squares, right? To help you see it better. So then you know that the way this is going to factor is going to be first plus last times first minus last. First being u and last being 8. So you would get u plus 8 times u minus 8. Okay? So that's one way of factoring a difference of squares using the difference of squares factoring formula, which is right there. Also, you can multiply conjugates very quickly once you know this rule by using the product of conjugates formula right here, okay? So make sure you get comfortable with those. These are very, very commonly used topics in mathematics. All right, go ahead and see if you can get the answer for these really quickly. All right, remember you're going to be using the product of conjugates formula, the f plus L times f minus L equals f squared minus L squared, right? All right, so what is playing the role of f here? 4. And what's playing the role of L? B, right? So what's f squared going to be? That's going to be 16 minus L squared. L is B, so L squared will be B squared, right? For the next problem, what's playing the role of f? Negative 4. And what is playing the role of L? B, right? So therefore, this is once again, notice you have to be in the perfect conjugate shape. The only difference between the two expressions being the difference in the sign, right? Notice negative 4, B, B. Only difference is the sign in the middle, and these two. Only if this is satisfied can you use this formula, okay? So now we're going to get negative 4 squared minus b squared, which is what? Once again, we get the same thing. So that should not be surprising, because it doesn't matter whether you square 4 or negative 4, in both cases you're going to get what? What's 4 squared? 16. What's negative 4 squared? That's also 16. So that answer should not be too surprising, the fact that those answers are the same. All right, make sure you get that before you may move on. If you recall, that is the second factoring formula we've learned about. The first factoring formula we learned about was just the opposite of the distributive property, right? So if you have AB plus AC, you can write it as A times B plus C. Notice when we write it the other way around, that's just a distributive property. So going in this direction, that's called factoring, okay? And here we say that A has been factored out of these two terms, all right? Leaving only what? B plus C. You can verify that your factorization is correct by just multiplying, right? So AB plus AC should go back to the original problem, right? Now notice the same thing will hold with subtraction as well. You would just get A times what? B minus C. So those are two methods of factoring that we've learned so far. One is the One is this method. I'm not calling these two different methods. This is the same method. It's the method of using the distributive property in reverse. The other one we've learned is this one. Either you can use a and b or f and l. It doesn't matter. A squared minus b squared equals a plus b times a minus b. Okay? Or yeah. Now remember, there is no formula for a squared plus b squared, so don't fall into the error. So watch out for this. A squared plus b squared, and this is a very common error, is not a plus b squared. So always remember that. You want to avoid that mistake at all costs. Okay? All right, and that's that for this topic here. All right, so here we're going to apply what we have learned as far as factoring is concerned to go ahead and factor these expressions. Now, remember, we're dealing with two different formulas we've learned. One is the formula that says a b plus ac equals a times b plus c. And the other one is our formula for difference of squares. F squared minus L squared equals F plus L times F minus L. And remember that the AB plus AC one works whether it's plus or minus. So we usually show it like that. So when you write it like that, this means that this formula works whether it's written with a plus or written with a minus. So these are actually two formulas lumped into one. Okay, so looking at the first one, we can see that it's going to be a case of a difference of two squares, right? So just determine what is your well, if you want, go ahead and actually write it as a difference of two squares like that, right? So now you can see the first is x and the last term is 3. So now we just simply apply these, right? Make sure you try this all on your own before you watch me do it. So we end up with what? With f plus L, so x plus 3 times f minus L, which is x minus 3. We're just applying this formula to this expression right here. Now, this one, it looks like, wow, I can't use this. This is more complicated. No, not at all. Because remember, you can treat the entire x plus y just as some number, let's say u, right? So you're just going to get u plus z times u minus z, right? So the point is just treat the whole expression here inside the parentheses as your first. So your first here is x plus y, and your last term is z. So now you're going to get what? F plus L, so x plus y plus z times f minus L, so x plus y minus z. And that's it. We just factored that. There's not much else you can do because there's nothing else we can do because there are no common terms we can combine, right, within those groups. So that's it. We're done. How about this one? It doesn't really look like either of these rules, does it? Well, if you look a little bit closer, you see that it actually does, because notice we have this rule, right? For this rule, what's important is to find out what it is that those two terms have in common, in this case x, right? And then factor it out. So we can go ahead and factor out an x and just tell me what's left. When you take that out, what's left? Negative 3 plus 5y, right? Quickly check to make sure, multiply it out, and you should get back to this. X times negative 3, that's negative 3x. and x times 5y, that's 5xy. So we've done it correctly, okay? And of course, you could check all of them by multiplying them out and making sure that you get the same thing, okay? It's always available to you, that option. All right, now we want to look at division a bit. Now for integer division, we as usual, we'll start with the chip model. Let's say we want to divide negative 15 by 3, right? So we're going to start with a group of all red chips. How many of them? 15 of them, representing negative 15. We're going to split them up into 3 equal parts. There'll be 5 of those negative chips in each. So basically, we see that the quotient of negative 15 and 3 is going to be negative 5. Okay, as far as the definition of division is given, just as we defined subtraction in terms of addition, we're going to define division in terms of multiplication. So we say that, let's put this symbolically, it'll be easier to understand. We say a divided by b is some integer c if and only if a is equal to b times c. Let's see if this makes sense. We know that 6 divided by 2 is 3, right? Notice that's the same thing as saying 6 equals what? 2 times 3. So this is how we define division in terms of multiplication, okay? So remember this important relationship between division and multiplication as we proceed. Okay, so here we have 12 divided by negative 4, and we're trying to see what that is, right? So let's just call it x, right? What is that going to tell you? That's going to tell you, therefore, that means 12 equals negative 4 times x, right? Now, what do I multiply negative 4 by to get positive 12? Well, it can't just be 3, because if I take 3, that negative 4 times 3 is negative 12. So what does it have to be? Negative 3. Because now notice, what's negative 4 times negative 3? That's positive 12, right? Which is, of course, just 12. Okay? How about this next one? Same way. We say negative 12 divided by 4 is some number. That implies that negative 12 equals 4 times that number, right? So what do I multiply 4 by to get negative 12? This time I do need what? Negative 3 as well. All right, and of course we knew that, because if we write it like this, remember the rules that I showed you for multiplication and division apply to both division and multiplication. So let me bring them back up. All right, so here are the rules that we had. So they work for division as well. So if I'm dividing 12 divided by negative 4, notice I'm dividing a positive number by a negative number. So I know the sign is going to be negative. Then I just need to take care of 12 over 4, which is 3. Of course, we're not generally going to be doing this technique to find the simple quotient, right? This is just so you can understand that the relationship between division and multiplication. This is not so that you start dividing in this manner, right? And of course, the same goes with negative 12 over 4. If we're actually just interested in computing that and not the lesson it's teaching us about the relationship between multiplication and division, then we just look at it and say, okay, we have a negative divided by a positive according to this table. Negative divided by positive gives me negative, right? So actually, let's go like this. Negative divided by positive gives me negative, right? To go from left to right. Okay, so that's going to give me the sign. Then I just take care of 12 over 4, which is 3. So once again, I end up with negative 3. All right. All right, so these we're going to do without having to go through all those steps, right? What are we dividing? We're dividing two negative numbers, right? Negative divided by negative, we know the answer is going to be positive. And 12 divided by 4 is 3. Now, don't put, when you type it into, say, for example, my math lab, don't type in that plus sign or that positive sign. Just type in 3, okay? How about here? Well, this is really just negative 12 over 5, right? If we know the output is negative, so I put the negative right next to the fraction line, and that's all I get. Look, 5 doesn't go into 12 perfectly, so we're just going to leave it as a fractional answer. And of course, if we're dividing over the set of integers, then, so this is the answer if we can use real numbers, right? Or even rational numbers. But if we're dividing over the set of integers, which is z or remember I, then this 12 divided by negative 5 is undefined. So be careful to make sure that what kind of answers are being sought. If you're allowed to do your operation only within the set of integers or within the set of real numbers. If you're dealing with the set of real numbers, that would be your answer, that fractional answer. But if you're only allowed to have integer answers, then you don't have one here. So it would not be well defined. So it does not exist. So negative 12 divided by negative 5 is not an answer that exists within the set of integers. Because remember, the set of integers is a set of all nice numbers, just both positive and negative ones. Right? And of course, this is not a member of this set. Okay? All right, let's go ahead and go back to the definition of division to do these next couple, just because we want to get practice with both types. So remember, we said A divided by B is C, implies that A is equal to B times C, right? It's actually, if and only if it's a double implication. We could have used equivalence as well. So, so here we're going to say AB divided by B is some number X, implies that AB should be this B times that X, right? Now look, A times B equals B times X. So what can you tell me about X and A? They must be the same, right? All right, of course, later on when we get more comfortable with all this and we don't have to use the definition all the time, if we see that AB divided by B, of course we're just going to say, oh, that's AB over B, right? And then we're going to cancel out the B's and we're going to write what? We're going to write A, okay? This one using the second one, the F, part F, using the definition of division becomes some number, let's say Y, implying that AB, well, let's say if and only if AB is that A times Y, right? And look at it. How can A times B be the same as A times Y? B and Y must be the what? Must be the same for this to be equality, right? So this implies B equals Y. And that is the answer to AB divided by A. Once again, so in other words, AB divided by A equals B. because remember, we called it y, and then we find out what y needs to be, which is what? B. All right. So, of course, later on, when we see something like that, we're just going to write it like this. And we're going to realize the a's cancel out, and we get what? We get B. All right. All right, now we want to talk about ordering integers. We've already seen ordering for whole numbers, remember? And we said if A is less than B, that means there must be some positive integer k such that A plus k equals B. So we're just saying, look, 2 is less than 5 because there is a number, namely what? Say 3, such that 2 plus 3 is equal to what? 5. Okay, so there's some positive value I can add to the smaller number to get the what? The larger number, right? So think of it this way. Let's look at some negative numbers to get you comfortable with them. Negative 4 is less than negative 1. Why do you think that is? What is the magic number that you have to add to negative 4 so that you get negative 1? 3, right? So they're not always 3. It just, these two examples I happen to pick, right? For example, negative 7 is less than 8. Why is that? Because if I take negative 7 and add what to it, do I get 8? I think I heard you say 15, right? Yes, you're right. Okay, so another way of saying that, okay, another way of saying that is to say that A is less than B if and only if B minus A is a positive integer. See, that's a nice way of putting it too, right? So A is less than B if and only if B minus A, right? So if you take the larger number and subtract from it the smaller number, you should get a what? You should get a number that is greater than, or an integer that's greater than 0. Not greater than or equal to, but strictly greater than, right? So again, let's see if that makes sense. We know 2 is less than 5, right? So is 5 minus 2 strictly greater than 0? Of course it is. It's 3, right? So that's actually probably the nicer, faster way of dealing with that, right? So A is less than B only if B minus A is greater than 0. Now, here are some important properties of inequalities. If x is less than y and n is any integer, notice that we can go ahead and add n to both sides, and that's not going to change the relationship. So x, that's still going to be less than y plus n. So let's look at an example. Let's say we have 3 is less than 7, right? Notice that I can go ahead and add 2 to both sides, right? And that sum, 3 plus 2, is still going to be less than 7 plus 2, right? So we maintain the direction of inequality as long as we add the same number to both sides. So we get 5 is less than 9, okay? Now, you don't have to just add a positive number either. You can add a negative number. So let's say you have 3 is less than 7. Can I do 3 plus negative 2 is less than 7 plus negative 2? Yes, you can do that too, because 3 plus negative 2, that's 3 minus 2, which is 1. 7 plus negative 2, that's 7 minus 2, which is 5. Notice that's still true. All right, the second property says, and this is really important when it comes to solving inequalities, if you have x is less than y and you multiply both sides by a -1 or any other negative, okay, that's going to switch the direction of the inequality. Let's see if that makes sense. Like, you know that, for example, 2 is less than 5, right? Now, let's take a look at the number line and see what that's going to translate into. Let me take this to a place where I can show you a nicer number line. Okay, now we know, for example, that 2 right here is less than 5, right? So let me mark them. So we know 2 is less than 5. Now, let's look at what happens if I multiply both sides by -1. I get -2 and -5. But look over here on the other side at -2. This program writer is so tough. I mean, he doesn't let you use any colors other than black. Of course, we have other solutions. Give me a second. Okay, here we are with the generous programmer. We have, all right, we know that 2 is less than 5. We multiply both sides by -1. We get -2 and -5. Now, have a look at -2 and -5 over here on the left side of 0. We have -5 there and -2 there. Which one is larger? You see, -2 is actually larger than -5. So things get switched around when we look at the negative part of the number line, right? So the correct direction for the inequality here would be -2 is greater than -5. Now, this is going to happen not just when you multiply by -1, but when you multiply the two sides of an inequality by any negative number. So, for example, if I have 2 is less than 5 and I multiply both sides by -3, same business. As soon as you multiply by a negative number, you need to switch the direction. So as soon as I say -3 times 2 and -3 times 5, without hesitation, I switch the direction of the inequality. So notice I get -6 is greater than -15, which is of course true, because look, -6 is right here and -15 is right there, you see? So you definitely would want that switch. -6 is definitely larger than what? -15. Visually speaking, of course, it's very easy. If you're given two different numbers on the number line, the one on the right is always larger than the one on the left, right? So that's the easiest way to tell which number is larger. All right, so that's that. Let's move on. All right, so this we already covered. The next one says if x is less than y and n is greater than 0, then you don't change the direction of inequality. In other words, if I just multiply both sides of this inequality, 2 is less than 5, by 3, then there is no need to change the direction of the inequality because it still stays true. So 6 is obviously less than 15. Okay? Now, we know that, for example, -3 is less than -1, right? Now, let's multiply both sides by +2. So we get what? 2 times -3. No need to change the direction. Remember, you only change the direction of an inequality if you multiply or divide. Makes no difference whether you multiply or divide both sides by a negative number. So here I get -6 is less than what? -2, which is also true. Okay? So the last one is just saying what I've already said to you in the other graphic I was showing you with the number line. If x is less than y and you multiply by a negative number, immediately switch the direction of the inequality. All right, now here we're going to solve these inequalities using some of the properties we've learned, right? We did learn, remember, that if you have a is less than b, then you can add the same integer to both sides. Notice that you can even subtract the same integer from both sides. After all, subtraction is a kind of addition, right? So this works as well. All right, and we also learned that if a is less than b, then a times c is less than b times c as long as c is positive, and a times c is greater than b times c if c is what? Negative. So it depends on what you're multiplying, right? So here I want to get x by itself, right, in this problem, right? So what do I need to do to both sides? I want to get rid of 3, so I'm going to subtract 3. So carefully, I get what? X. Notice I'm applying this property, so I don't need to change the direction of the inequality. So I get x is less than what? Negative 5. So if you want to write the solution set up really professionally, you would say the solution set is the set of all x such that x is less than negative 5, comma or and makes no difference. X belongs to the set of integers, like that. Okay, that would be the solution set of this problem, because we're dealing with integers only. Like if we were dealing with real numbers, we would have put what? X belongs to the set of R, or real numbers. All right, so how about this next one? Again, always try before you watch. Remember that. So negative x minus 3 is less than 5. Now let's go ahead and try to get x by itself. So that means we're going to go ahead and add 3 this time, right? So now we end up with negative x is less than what? Less than 8. No need to switch the direction. Sometimes people get too trigger happy with that. You only switch the direction of an inequality if you multiply or divide by a negative number. We haven't done that. But now we're going to do that. Look, I have negative x and I want x. So what can I do to negative x to turn it into x? Well, there are two things I can do. I can either multiply it by negative 1, right? Or I can divide it by negative 1. Either case will give me what? X. So it's your pick your favorite operation between the two and apply it. I'm going to go ahead and multiply both sides by negative 1. What do we have to do? The moment, the instant we multiply both sides of an inequality by a negative number, we don't wait till the next step. We don't do anything like that. We immediately switch the direction, okay? So now what do we get? We get x is greater than negative 8. If you were to write the solution set up, it would be what? The solution set contains all x such that x is greater than negative 8 and x belongs to the set of integers. You could use z. Let me use I this time so you don't think I have anything against I. No, I'm just used to z because I've used it for so long. All right, like that. All right, so there you go. That's how you do those. All right, here's the last problem we're going to look at for the lesson proper. Then we'll look at some homework problems. So here we know that we start with x is less than or equal to -2. And if that's the case, we want to get an expression for or find out what the values of 5 minus 3x will look like if this is true about x, right? Well, notice that if I'm going to get to 5 minus 3x, the first thing I should probably do is go ahead and take this x and turn it into a negative x, or even negative 3x by multiplying both sides by what? By -3, right? So let's go ahead and do that. So we're going to go ahead and multiply both sides by -3. So what do we need to do the instant we do that? As soon as we multiply both sides of an inequality by a negative number, we need to switch the direction, right? So what do we have now? We have -3x is greater than or equal to 6, right? What's the only thing we need to do now? We need to go ahead and add 5 to both sides, right? So I can put -3x plus 5, or, it will look nicer if I write what? 5 minus 3x. Notice these are the same, okay? So I'm going to add 5 to both sides like this. And I'm going to end up with 5 minus 3x is greater than or equal to 11, right? So in other words, 5 minus 3x will have values that belong to this set, the set containing 11, 12, 13, etc. That's where the values of 5 minus 3x are going to be. I'm not writing a solution set because that's not what I was doing. I wasn't actually finding the solution set of an inequality. I was given instructions to find certain values, and we have found them. So we don't need to write the solution set here. All right, that's it for the lesson. Let's go ahead and take a look at a couple of homework problems together. All right, so here we have a problem that states that the number of students eating in the school cafeteria has been decreasing at the rate of 25 per year for many years. Assuming this trend continues, write a multiplication problem that describes the change in the number of students eating in the school cafeteria for each situation. Complete parts A through D. So if we wanted the change over the next 5 years, basically we're going to have 5 times what? This is a decreasing rate, right? So you actually would multiply 5 by what? By -5, right? And you would end up with -125. Now, if you want to know the situation 5 years ago, right, you would want to multiply -5 by -25. That tells you what? There were 125 more students in the cafeteria 5 years ago. So the change over the next n years, that's going to be just like we did with the first part, 5 times -25. We're just going to go n times -25, or -25n. For n years ago, of course, we're going to go -n times -25, and negative times negative is positive, so we get 25n. All right. All right, here we have some problems where we're computing powers with negative bases in some of them. Now, be very careful and pay attention to the fact that when you take a negative number, let's say, for example, -2 as in the case of the first problem, right? So if you take -2 and you cube it, notice that's basically -2 times -2 times -2, right? So when you have an odd exponent, you're always going to end up with these pairs of positives. Like two negatives will make a positive, right? The product of two negatives. And then at the very end, you're going to have that odd man out, right? Which is going to turn the entire product into what? Negative, right? So anytime you have a negative number and an odd exponent in a power, the result is going to be negative. And whenever you have a negative number as the base and the exponent is even in the power, the result is going to be a positive result. Now, in the special case of -1, notice that if you have -1 to an odd power, right? -1 is very special, right? It's very easy to operate with. The answer is actually just going to be -1, no matter what the odd power is. -1 to the power of 1001 makes no difference. That's just going to be -1. And if you take any even power of -1, that answer is always going to be 1. Okay? So pay attention to those facts. All right, so I'm just going to do a few of these just to get you on the right track. We already looked at the first one. We know it's going to be negative. So that's just -2 cubed. So it's going to be -8, right? What do you think part E is going to be? See? You have -1 and you have an even exponent. It's a no-brainer. What is it? 1, right? How about part F? -1, and that's an odd power, no-brainer. That's going to be -1, right? What kind of an answer do you expect for this part, for part B? Positive or negative? I heard you say positive. I agree. Yeah. Okay, so what about a problem like this, right? Well, this goes back to the order of operations that we discussed in another screen, right? So with this, make sure you follow the order of operations and you'll be good to go. The operations involved here, we have multiplication, another multiplication, and the rest are addition and subtraction. So let's go ahead and start with the first. We go left to right and perform as in we encounter the multiplications. So 10 minus 5 times 6 is 30. And then notice that was negative times positive, so we kept negative. Now here we have negative times negative. That's what? Positive, and then 20. And then plus 4, right? So now we know that 10 minus 30 is -20, right? So we have -20 plus 20 plus 4, right? But what is -20 plus 20? Those cancel out, right? So what's the final answer? Just 4. Okay? Now, this is an easy problem if you understood what I said to you in the beginning. Okay? Just think about those things. And yeah, you should be fine with the rest. Okay? Here, you're using the quotient rule, obviously. Let me just do this last one. So with the quotient rule, when you have x to the m over x to the n, that's x to the what? M minus n. No change to the base x, right? So here we have what? -2 to the 5 over -2 to the what? To the 1. It's not written there, but you know it's there. So you're just going to get what? -2 to the 5 minus 1, which is 4. Then go ahead and figure that out. Okay? Should be in good shape now. All right, here we're going to be factoring, and most of these are pretty simple. I just want to get to a few that may be a little bit different from what we've already seen. So here we have f squared on this one. F squared plus fg, right? Well, what can you factor out? Remember, f squared you can think of as f times f, right? So now you have f times f plus f times g. Do you see a common factor? F, right? So go ahead and factor out an f. And when you take that out, what's left? In other words, what's there other than the red parts? Just f plus g, right? Now, go ahead and multiply it out. Make sure you get the original expression. What's f times f? F squared. And what is f times g? Fg. Okay, so that's correct. What do you get for that? So we have xyz plus xy minus x, right? So we have a common factor, notice, in all three of them of x. So we go ahead and factor the x out, and that leaves us what? Look here, it leaves us yz plus, this one leaves us y minus, here is where a lot of students make mistakes. They just close the parentheses. No, there's something that's left here. What is it? It's 1. Also remember, if you don't write that 1, when you multiply it back out, you won't get the original problem. Now watch. X times yz, that's xyz. X times y, that's xy. And x times -1, that's -x. Okay, so that's how you handle something like that. For this one, I'm just going to give you a hint. It's of the form of difference of squares. Just write it as a difference of squared. In this case, it's what do you square to get 36f squared, and minus what do you square to get 25g squared. What goes in here is going to be your f. What goes here is going to be your L, and then you can easily factor it using the fact that f squared minus L squared equals quantity f plus L times quantity f minus L, like so. All right, so here we have a lab, and the temperature of various chemical reactions is changing by a fixed number of degrees per minute. Write a numeric expression that describes each of the following if all times are on the same day. So here we have the temperature at 8 a.m. is -9 degrees Celsius, and it increases by d degrees per minute. So here you're going to start with your -9, and you're going to add d. So see, it's increasing by d. Let me show you real quickly. It's increasing by d degrees per minute, right? For m minutes times m minutes, right? So notice these minutes will cancel out, and you're just going to get dm. Now, because we're putting the degrees at the end there, we don't need to put them here, right? So notice you just get the dm. So you start with the -9 degrees, and you add to it this many degrees, and you end up with -9 plus what? dm. All right, so here we start at, in the second part, you start at 20 degrees. That's where that comes from. And if it has been dropping by d degrees per minute, what was the temperature m minutes before? Be very careful. It's been dropping, so that means before it was a higher temperature, right? That's why you have plus dm. They're not asking m minutes from now. They're saying what? M minutes ago, right? So it becomes, that's when you have the minus a negative, so you get two negatives, so you get a positive, right? The temperature at 8 p.m. is 13 degrees Celsius. It's been increasing every minute by d degrees. What was the temperature m minutes before? Now this one, because it was increasing, that means it was a positive situation. So in the past, you would what? You would have to subtract dm. All right, that's how you would approach something like that. Okay, in here we're using the tedious notation, but keep in mind that we're squaring a minus 1. So you know a minus 1 can be written as a plus negative 1, right? So times a plus negative 1. Then we're going to distribute the a plus negative 1 by a, and plus we're going to distribute the negative 1 by the a plus 1 by negative 1 as well. So we're going to multiply the a plus negative 1 by negative 1. So we basically, when we multiply this out, we get what? A squared plus negative 1a, right? And then plus negative 1a, right? Plus negative 1 times negative 1, right? So if you simplify that, you end up with a squared plus negative a plus 1. Notice there's two of those, same sign. You combine and keep the sign. So a squared minus 2a plus 1. And of course, you can write it like that. Now, as you know, you start dealing with more advanced students, you can of course do this in a much nicer way. For example, I've shown you the table method, right? You have a minus 1 times a minus 1. So that's what both sides are going to be the same, because we're trying to find out a minus 1 squared, right? So notice in here we get what? A squared. In the second box here, a times negative 1, that's going to be negative a. Negative 1 times a is also negative a, and negative 1 times negative 1, that's going to be positive 1. So this time, notice these don't cancel, so they have to be combined. They are like terms, so those two are going to get combined, right? So we're going to get a quantity a minus 1 squared equals a squared from here. Combine those, so you get negative 2a and then plus 1. So that's what's coming soon. It's going to be much less tedious than that, but it is important to understand these, because this is how elementary students are going to be thinking and needing the guidance for. All right, so here's a question that tricks a lot of people, because they're giving you these two expressions and multiplying them, and they're saying, can you use the difference of squares formula? Remember, the difference of squares formula only works if the two expressions are conjugates. That means if you have x plus y here, you would have to have what? X minus y. The exact same two terms, the only difference being the sign between them. And that is not what we have here, so we wouldn't be able to use the difference of squares formula. So this one we could have, or it doesn't mean you can't start with a negative. You can do that, but as long as the next one was negative x plus y. So these two are conjugates as well. So this we could have done using the difference of squares formula, and this one we could have multiplied out using that formula, but not the one that's given. Okay? All right, so here we have a student that has computed this particular expression by doing this. So they've combined these two to get negative 10 and multiplied by negative 3 to get positive 30. So how would you help the student? Well, the student obviously is just going from left to right and doing whatever they encounter, but as you know, that's not how the order of operations works, right? With the order of operations, this multiplication has to be done first, and then anything that comes after that. So you could guide the student by teaching them about the order of operations. So what would be the correct answer, or the correct way of doing this? Well, you'd want to take care of this multiplication. So that's going to be negative 8 plus 6. So now you go ahead and take care of the addition to get negative 2. All right. Okay, so here you're given that Tuesday the temperature was negative 3 degrees Celsius, and on Saturday it was negative 9 degrees Celsius. Was the temperature colder on Saturday or on Tuesday? What do you think? Remember, colder means lower temperature, right? And notice that this, if you look at the number line, -3 is here and -9 is somewhere to its left. So which one is colder? That's colder. All right, and how do we know? Because you can either say because -9 is less than -3, or you can say because -3 is greater than -9. So depending on what kind of format they're setting up the answer in, you would put it like that. Okay, you can see here, like they put it like this, so you would want to go with that particular answer that you came up with. All right, so that should do it for this lesson. You take care of yourself, and we'll see you for the next lesson.